In this lesson, we're going to look at charges, and in particular, we're going to investigate how a net charge comes about. Okay, a net charge. Let's start by sharing with you our lesson objectives. There are four of them. Give yourselves about 20 seconds to be familiar with them. Let's start by showing you a model of the atom. Here we have a model of the atom that was prevalent, if I'm not mistaken, sometime, 1700s, 1800s. The plus signs there remind us that there is a region, right? A region that has different properties compared to the region with the negative signs, okay? And you'd be quick to point out that the plus signs there stand for a positive charge or positive charges. And the negative sign, the minus signs, stand for negative charges, right? So there are two kinds of charges. One kind is the positive, the other kind is the negative charge. Now, they don't have to be named that way, okay? But when they were thought about, when they were dreamt up, okay, they were just called plus and minus, positive and negative. Now here's another model of the atom for you. Okay? At the center, you have the positive charge, okay, and you have negative charge around this center. Now, your atom, as we know now, is made up of three particles, right? Three building blocks, if you may. You've got your protons, which have a positive charge, your electrons that have a negative charge, and your neutrons with no charge, right? Neutrons are neutral, they have no charge. Now, in an atom, the center, right? Center is called the nucleus. The center of an atom is the nucleus. It's what we have here. The nucleus is made up of protons and neutrons. And because protons have a positive charge and neutrons have no charge, together, right? Together, they have a net positive charge. And for this reason, the nucleus has a net positive charge. A lot of the mass of the atom is found in your nucleus, right? It's a very dense region of your atom. Around your nucleus are your electrons. Okay, electrons have a negative charge. Now, this model of the atom is known as the planetary model. Now, this is called the planetary model because it likens itself. It's just like our solar system. You have the sun at the center. In this case, you have the nucleus at the center. The sun is massive. It's got a lot of mass. Okay, so much mass, more so compared to the planets. And here, the nucleus has a lot of mass also. Okay, in fact, I would say more than 95%. Okay, don't quote me on that. I might be wrong. More than 95% of the mass of the atom goes in the nucleus. Probably more. And the electrons are orbiting around your nucleus in the same way that the planets in our solar system are orbiting around the sun. Okay, so for this reason, this model of the atom is the planetary model. Now, no one has seen an atom. Okay, you can use, an electron microscope. Okay, but ordinarily, right, with your eyes, no one has seen an atom, let alone the parts of an atom. So keep this in mind while we're studying this unit, this topic, right, now for this lesson even. We're looking at things that we cannot see. We're studying things that we cannot see. And we use models. Okay, we use models to help us do that. Let's have a look at three atoms. Which atom here is positively charged? If you answered the atom center, you're correct. Because I have one positive charge, so that's two positive charges, and I have one negative charge. So the net charge is I have a +2 minus 1. That gives me a net charge of +1. Well, how about the atom with a negative charge? If you answered the atom on the right, you are correct. Look, I've got one positive charge and two negative charges. So the net charge is +1 minus 2, that gives me a minus 1. Okay, a net charge of minus 1. Well, how about the atom on the left? What net charge does it have? If you answered 0, you're correct. I have 1 positive charge, plus 1, 1 negative charge, minus 1. So the net charge is plus 1 minus 1. This gives me 0. Okay? Now, really, we should not be saying no charge because there are 2 charges here, 1 positive, 1 negative. But the sum of the charges gives us 0. Okay? So we say that the atom is electrically neutral, or neutral for short. Okay, neutral for short. Now let's go about writing down some observations. Okay, an atom has a net positive charge if the number of protons is greater than the number of electrons. In the same way, if the number of protons is less than the number of electrons, my atom has a net negative charge. Now, if it so happens, and it does every once in a while, the number of protons is equal to the number of electrons, then I have a neutral atom. Let's have a look at the next slide. Here, we're going to count the number of positive charges and negative charges, right, in my atom. Let's start with the atom on the left. The number of protons, positive charges, is 1, 2, 3, 4, 5, 6. I'm now going to count the number of electrons. These are the negative charges. 1, 2, 3, 4, 5, 6. 6. Because the number of protons and the number of electrons are the same, my atom here is neutral. In other words, the net charge is 0. Let's go ahead and do the same for the atom in the middle. The number of positive charges, okay, the protons, 1, 2, 3, 4, 5, 6, 7, 8. The number of electrons, negative charges, 1, 2, 3, 4, 5, 6, 7. The net charge here, because the number of protons, positive charges, is greater than the number of negative charges, the net charge here has to be positive, right? The net charge here is positive. Now, if I add the number of positive charges to the number of negative charges, I will get a 1. Okay, that's an 8 minus 7. Last but not the least, the number of protons here, 1, 2, 3, 4, 5, 6, right? 6 positive charges. And the negative charges representing my electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9. The net charge here is going to be negative because there are more electrons than protons. Now I see that there are 3 more electrons than protons, so it's going to be a minus 3 net charge. Now protons and electrons, they are charged objects, they're charged particles. But have you thought about how we measure the amount or the quantity of charge? Okay, we do so using what's known as the Coulomb. Okay, Coulomb is a measure of charge. The bigger the number in coulombs, the more charge an object has, and vice versa. Right? That person there is Coulomb. I believe he is French, and he did a lot of work on electricity, on magnetism, and to this day we honor him and his achievements, his hard work, his dedication, his perseverance by using his name when we measure charges. 1 electron has a charge of negative 1.6 times 10 to the minus 9 coulombs. Negative because it's an electron. 1 proton has a charge of positive 1.6 times 10 to the minus 19 coulombs. Positive because it is a proton. All right, let's go ahead and look at this table. I am given charges here on the third column, and I'm asked to do two things in the middle column. Number one, I need a number, and number two, I need to decide if I am counting electrons or protons. Okay, protons or electrons. Okay, so give it a shot. Let's first decide on whether we have protons or electrons. Okay, so look at the sign here. That's a negative. So that means for A, we have electrons. Now look at the sign here. For B, it looks like we have protons. Let's move on to C. That's a minus sign there. That suggests we have electrons. For D, it's a positive sign, so that better tell us we have protons. Last but not the least is E. Well, the negative sign tells us these are electrons. All right. Now refer to the previous slide and refer to this slide. Let's begin to calculate then the number of protons in objects A, B, C, D, and E. Okay, let's look at object A first. Okay, how many electrons are there in object A? Hey, that's right. How many electrons are in object B? Sorry, let me take that back. How many protons are in object B? Object C has how many electrons? How about D? How many protons does D have? The last, and definitely not the least, object E has how many electrons? All right. That takes us back to our lesson objectives. Which lesson objective did you fulfill? This is our first session on our next unit. Okay, our next unit is on electricity, and we were looking at charges today. We said that there were two kinds of charges, a positive charge and a negative charge. And we said that we can add these charges. When we add these charges, we get what's known as a net charge. If the number of positive charges or protons are greater or is greater than the number of electrons, the net charge is positive. And you have to count the number of protons here and subtract from that the number of electrons. If the number of protons is the same as the number of electrons, the net charge is zero. Another way to say this is the object is electrically neutral. The last, if the number of protons is less than the number of electrons, the net charge is negative. Now you have to count the number of protons and subtract from that the number of electrons.